Welcome back to the series. This should be the last episode in the introduction course, and we'll have to wait till next week to be able to even access the first data science one. So this one might be a little bit longer because we actually have to go through a whole module, and there's like a little tiny thing at the end where it says like pick either data analyst or data science. So we'll try and get through it all. Let's start her off. Data analysis and presenting results. Okay, tackling statistics. So once we've cleared out all the garbage from the data, we can finally start working on the most exciting part, figuring out our final results and presenting them to the customer. In this lesson, we'll learn the principles of grouping and sorting data, calculating statistical data, and creating visually impactful reports on our findings. Okay, we'll analyze Yandex music data. Okay, so the idea of merging the music and radio services was tested on a small batch of users. The results of the test are summarized in the CSV file that you will be studying. The results that come from analyzing that kind of data are referred to as metrics, entities with values that depict user experiences. One of the most important metrics is happiness. In our data, happiness is the average time a user spends listening to music in a given period. For our task, it's a day. The longer a user listens to music, the happier they are. Our task is to find the happiness value and see how it's changed since the last experiment. In data analysis, visualizing the results is crucial so that customers can evaluate them. Our client is a business. They have massive amounts of data, server capacity, and thousands of people's time on the line. Answers can be unpredictable, just as in real deal experimental science. How accurate our answers are depends on our proficiency with statistical methods, as well as the quality of the source data. Before beginning your calculations, be sure to check that you've prepared your data correctly. Familiarizing yourself with the data, a quick recap. So we already know all this. I'm just going to kind of skip this. It's going to teach you how to read from pandas, a CSV from pandas, print out the data frame, look at the head, evaluate sums. Okay, so they want us to read data from the file music log upd, which they've already put here, and print the first 10 rows. So we do that through df.head and put 10 in the parentheses because we want to print the first 10 lines. Okay, and if we hit play, we shouldn't even have to print it. Well, maybe we do. Yeah, I guess we do have to print it. If this is in a Jupyter notebook and you do head, it'll automatically print it because it's like the only thing in your cell. But okay, so we can check that. Easy peasy. Next, get a list of column names by requesting the columns attribute. This is really a repeat because we already did this. So we do print df.columns. Okay, so we hit play. Check that. All right, cool. Next. Okay, so then they want us to do NA number is going to be equal to the number of null values in the data set. So remember, we can do that df.isnull.sum. We can print that NA number. Ooh. Hit play here. 0 null values. I guess I was going to use NA instead of isnull. Still 0 though. Okay, next. Calculate the number of duplicates in the data set and save the result to duplicated number. Duplicated number is going to be equal to df.duplicated.sum, and then we print that duplicated number. Oh, this is a function, so we need 2 parentheses after it. Still 0, let's check that. So this data looks pretty clean. Correct, next. Grouping data. Data analysis begins with dividing data into groups based on a particular feature. This is called data grouping. It helps us study data in greater detail so we can later seek correlations between various groups. Grouping is feasible if the data can clearly be broken down by significant characteristic and also if the resulting groups are applicable to the task at hand. For example, it's easy to use grouping when working with data on every purchase made at a supermarket. You can estimate the busiest hours at the store and solve the problems related to peaks in traffic. You can also calculate the average sales amount, which is usually a key metric for stores. The stages for grouping data can be summed up quite well by the phrase split, apply, combined. Split is splitting into groups based upon specific criteria. Apply is applying a chosen method to each group individually, for example, calculating the size of the group with the count method or summing with the sum method. Combining is aggregating the results in a new data structure, usually a data frame or series, depending on the conditions of how it was divided and the method executed. The pandas library comes equipped with excellent grouping tools. Let's learn how we can use them in the example below. We'll be analyzing the data on exoplanets or planets outside the solar system. Orbiting observatories have already mapped out thousands of these celestial bodies. They are located within space telescope images by our fellow data analysts. Let's search for an exoplanet similar to Earth. It could become a future colony or intelligent organisms already live there, and someday we'll have to make contact with them. A data frame with data on several thousand exoplanets is stored in the exoplanet variable. Let us take a look at the first 30 rows. So they call head and they call 30, so they get the first 30 rows. Okay, in the image below, the split, apply, combine principle is applied to the table exoplanets. Let's see how things are looking with our search for exoplanets. First, we will make groups from the data with each group representing a year. Then the count method will calculate the size of each group. At the end, we'll receive a new data structure where each group encompasses a year and the number of exoplanets discovered during that year. Pandas has a groupby method for grouping data. This method accepts the name of a column as an argument for grouping. Here's how it works when grouping exoplanets by year of discovery. So you can see they do group by and then discovered, because discovered is a column. Okay, applying the group by method to a data frame creates a special type of object, data frame group by, making it grouped data. If we can apply a pandas method, the data will become a new data frame or series data structure. Use the count method to calculate the number of exoplanets grouped by year. Okay. The outcome of executing exoplanet.groupby_discovered.count code is a new data frame. Right off the bat, you'll notice a trend in the data frame. The number of discovered exoplanet increases almost every year. If you have to compare observations according to one attribute, apply the method to data frame groupby with one chosen column. We're primarily interested in the radii of exoplanets, and we're looking for an Earth-like planet. Let's get a table with a single column radius. So then once they get that, they print the exo number. We've acquired a series with a number of exoplanets with pre-established radii is listed for each discovery year. Let's observe how the average radius of discovered exoplanets fluctuates from year to year. In order to do that, we will add the radii of planets discovered in a specific year and divide by the total number of planets, which we already know. The sum of the radii is calculated by using the sum method. It's super stellar that series objects can be divided by one another. It allows us to divide the sums of radii by the number of exoplanets without using a loop. Our tools are becoming progressively more precise. Newly discovered exoplanets are more and more similar in Earth in size. Okay, so now we're basically going to apply that to the happiness metric. So let's try and track down a user ID for one of the users from our list of music lovers. To do this, we must group the data on the user in order to compile song genres they listen to. Group the data frame by the user ID column. We do df.groupby. We want to group by genre underscore group, by user ID, sorry. And save the results to genre grouping. Calculate the number of genres that users have chosen using the count method and specify that you're only selecting a single column genre name. Store the result in genre counting. So this is going to be equal to genre grouping dot count. And what do we want in that? We want the genre underscore name. And so then potentially we can do print genre counting dot head. Also, I think I did this part wrong. Let's see what they do up here. So potentially we do group by, then do genre name, and then do count. Let's just see what this gives us. Can check it. Okay, so I think maybe this goes before the count method. Let's scroll up a little bit, see if there's something above here. Yep, so they're doing that, exactly what we're doing here. So we grouped by user ID, and then we're grabbing the genre name. Oh, we're supposed to print the first 30, so it should be head 30. Let's check that. Correct. Next. Okay, so people who listen to more than 50 songs a day might have a wider preference range. In order to confirm this, we'll have to devise a multi-purpose tool. Write a getHeavyUser function which accepts a certain grouping as its group's argument. The function should sift through the entire grouping. There are 2 elements in each group, a group name with an index 0 and a list of values with index 1. When the function finds a group in which the list contains more than 50 values, it returns the group name, the value with element 0. Okay. So if the length of the group data is greater than 50, if the length of group data is greater than 50, then save the element group name to the variable user. And then return user. Is that all at once? Okay, so let's just check that. Correct. Next. Call the getHeavyUser function and pass the genre grouping as an argument. Save the result, the user ID of an unknown music lover, to the variable user ID and print the value. Okay, so user ID is going to be equal to getHeavyUser genre grouping. Okay, and they want us to print user ID. See if that works. Looks good, check. Correct, next. Sorting data, searching for anomalies in a group be it a group of planets or music lovers, is primarily a search for champions or objects with features that stand out for different reasons. Entire tables or individual groups can be studied when you sort rows by column. Pandas does it with sort values method, which possesses two attributes: the by column name and ascending true. So this is kind of like when you're like looking at like Amazon or something and you sort by something. It's like a filter almost. You're already familiar with this attribute because of the similar method in Python. The sort method like has a typo here. The exoplanets that are most interesting are close in relation to the size of Earth. Do any exoplanets like that exist? To find out, let's sort by radius in ascending order. Okay, so then they just call this sort values functions by equals radius. Turns out that several of the exoplanets that have been discovered are actually closer in size to the moon than Earth. Let's get a list of exoplanets with a radius less than that of Earth. Take a look at how the logical operator here is less than plays into how the columns elements are selected, while needing this technique more once in the future. Okay, so they're just doing less than instead of Okay, but the list is so long that we're better off breaking it down. Earth-sized exoplanets have often been discovered in the previous decade. We can look at a list of discoveries for each individual year. For example, take the year 2014. Again, note the logical operator equals equals. We've added both conditions together to save time. Pandas has a logical operator AND to handle this, which is similar to the AND operator in Python. And then they sort the results by radius in descending order. The largest planet, Kepler, so on. In the meantime, let's apply this technique to our biz. Okay, you discovered a music lover in Yandex music table with unique data. This user has listened to more than 50 songs in a single day. Acquire a table with the songs they listen to. In order to do this, request rows from the df data structure that meet two conditions. Okay, the value in the user ID column must be equal to the value of the user ID variable. Okay, so what they do, df, let's do. They don't tell you how to store this, do they? Oh, yeah, it says music user, okay. Music user is going to be equal to data frame, where data frame user underscore ID equals user ID, and the listening time cannot be equal to 0. Okay, so df user ID, df total play seconds is not equal to 0. Okay, then we print music user. Let's see if that works. Nope, it doesn't like something I did here. It's probably in the way I set this up. So let's see. So they have theirs in parentheses. Should probably put ours in parentheses too. So they do the data frame, they do a square bracket, then they do parentheses, then they do the condition is equals user ID in parentheses and new parenthesis df total seconds is not equal to 0, end parenthesis okay, so let's see if that works. I have an extra Maybe it doesn't like my not equal to. Oh, I also, this total play seconds needs its own square bracket. Okay, so not equal to 0, and then that one ends. Okay, I think that's right. Let's see if that works. Okay, there we go. So let's check that. Correct. Next. Now we'll find out how much time this user has spent listening to music of each genre. Group the data of the music user table by the genre name column and sum the values in the column total play seconds. Okay, so they want us to do sum music user equals music user dot group by genre name, and then we want the total play seconds, and we want the sum. Okay, and then we print the value, sum music user, and hit play. Seems about right. We'll check it. Made a mistake somewhere. Group by the genre name column and sum the values in the column total play seconds. So potentially we could put this square bracket after we sum it. Gives us the same thing. Maybe it's just something in their code they check. Nope. It was because I had there was an extra print music user under here, and so that was putting some output that they didn't want. But our statement was correct. It's just music user dot group by the genre name, get the total play seconds. You should be able to put this either after the sum or before the sum, and it should be the same thing. But they did accept that. Okay, so next. And it looks like our music lovers' preferences are beginning to emerge. However, song lengths can vary greatly from genre to genre. It's important for us to figure out how many songs from each genre the user has played. Group the data by genre name column, then calculate how many values are in the genre name column. Save the results to count music user variable and print its value. Okay, so group the data by genre name column. Okay, do they want us to do some music user or probably just music user, right? Music user equals df. Oh, I'm silly. Count music user. I think it's going to be the same thing we just wrote, except it's going to be count instead of sum. Count music user is going to be equal to music user dot group by genre name. Then they want the genre name column and they want us to count, right? And they want us to print the count music user. So let's see if that's correct. Comment out the print sum command from the previous task so it doesn't get in the way. So that's why I didn't do the first time, you know. So we should comment that out, play this. Okay, so you can see like electronic is probably their biggest one, or I guess pop is, and so on. That's correct. Next. Task 4, we don't need to position the largest values at the top, or we need to position the largest values at the top so the user preferences are readily apparent. So sort the data in some music user grouping in descending order. Caution when applying the sort values method to a series with a single column, you don't need the by argument, only the sorting order. Save the results to the variable final sum and print its value. Okay, so we comment this out from the previous, and then they want us to do some music user dot sort underscore, or I guess values. Sort values, and they want descending. Is that what it's called in this? I think it's called descending. Let's see. Here we go. It's ascending. So ascending equals false. Okay, and we store that in final sum. And print final sum. So let's play that. You can see rock is the biggest one, I guess. Correct. Next. Now we will have to do the same with the number of songs the music lover has listened to. Sort the data from count music user grouping in descending order and save it as final count. So you basically can copy paste this. We also need to print, comment out this final sum print statement. So we call this final count, and it's going to be equal to count music user dot sort values ascending equals false, and print its order. And check that. Oh, I printed final sum, not final count. I thought that looked familiar. So battle for pop and rock, I guess. Okay, next. Descriptive statistics. The music lover turned out to be just as devoted of a fan of one specific genre as listeners who only listen to 5 songs per day. Studying the remainder of the music lovers confirms these findings. This means that our audience is homogeneous in musical taste and behavior. We can use the attributes of average listeners in order to evaluate listeners' overall happiness. To paint a picture of the average user, you need some descriptive statistics. We'll need the 4 different measures from descriptive statistics to numerically describe the data in our simple task: maximum, minimum, median, and mean. The largest and smallest are typically calculated based upon one attribute. For example, this way we can get the minimum and maximum number of seconds spent listening to the song. The total play seconds column, called the max method. So longest is over an hour. We request to the row at which that occurs at by using the equals equals. Then we look for the minimum value. Okay. Now they're doing like average and they're doing median. This is like all stuff you learn in a basic like pre-algebra class. Okay, get a table with the songs in the most popular genre pop. It's important to capitalize it, excluding skip songs. Save the results to the pop music variable. Okay, so pop music is going to be equal to df, where df genre name is equals to pop, and the listening time, df listening time, I guess it's total play seconds, isn't it? Total play seconds is greater than 0, right? Because that means that they actually didn't skip it. Okay, so we put these in parentheses. I don't think we have to, but I think last time I messed up just because my bracket was in the wrong place, my square bracket. Okay, and we can print this. Okay, and check that. So it says exclude skipped tracks. Which I thought I did because we said 0, it's greater than 0. But maybe there's some other way to get that. Does it have like a skipped column? Let's see how they want us to get. That one was, the problem was it says it's supposed to be not equal to 0 instead of greater than 0. They're similar, and I actually think greater than is better in this case, but, you know, because -1 shouldn't be allowed, but they wanted not equals to, so that's what made it work. So next. Find the maximum listening time for a pop song, then save the result to pop max play total variable and print its value. So we can do pop music max total play is going to be equal to pop music where we do total play seconds dot max, and then they want us to print pop music max total play. $785 seconds. It's a long time. Correct. Next. Get the row from the pop music table with the info on the longest listening time for a pop song and save it to pop music max info. Pop music max info is going to be equal to df, I guess we can do pop music where pop music total play seconds equals pop music max total play. Okay, and then they want us to print that row. Oh. Hit play there. Check it. Correct. Next. Dig for the minimum non-null listening time for a pop song. Save it to the variable pop music min total play and print the value. Okay. Pop music min total play is going to be equal to pop music at total play seconds dot min, and then they want us to print this value. Okay. Correct. Next. Print data about the pop song that was turned off faster than the other song played. Save the results to pop music min info. Comment out this other output. Pop music. It's almost like we should just copy and paste this from the previous one. It's equal to min total play print pop music min info Okay, next. Calculate the median listening time for pop song. Save the results to pop median. Okay, so this is going to be the same thing, just median at the end. It's getting tedious and repetitive now, isn't it? Ooh. Pop music median. Okay, check. Correct, next. Calculate the average listening time for pop songs. Pop music mean. Oh, forgot to comment out this last one. We'll check it. Correct. Next. tend to stay the same from genre to genre. There are music fans who are eager to listen to pop for thousands of seconds. There are also fans who skip half of the songs from the very beginning. Judging by the median listening time, they listen to the other half of the songs nearly to the end. So what about the task the manager has set up for us? You're finally ready to solve it. You have the tools for grouping and sorting data as well as calculating statistics. With these tools, you can help any company. Before the start of the experiment, the happiness metric in the Yandex music was 33.154. If listening times increased, then radio had a positive effect on the music service and the data could vindicate a final decision. But if the metric decreased or remained the same under conditions unaffected by other factors, then the radio had a negative effect or didn't make a difference at all. We would have to figure out why regardless of the results. Every product team decides for itself how to calculate a happiness level. As for Yandex Music, it's user median listening time. We have to calculate the happiness metric and prepare a summary table where we will place all the data to answer the question. Here's how the happiness metric is calculated. We calculate how long every user listened to music. In order to do this, group the data frame by user, sort the data by user, and pick the first 1,000 recordings. Calculate the total listening time, find the median value. Analysts regularly show their work to non-technical people such as project manager, marketers, and upper management. These other people might not know all the terminology that analysts use. Make sure your report is easily understandable to a wide audience. It doesn't have too much detailed annotation. At the same time, don't sacrifice content for simplicity. In the later courses in the Data Analyst series, you will learn how to add graphics as well as other means of visualization to your reports. Here, the task suggests that a clear and demonstrative table with key company indicators will suffice, but the table's level of detail and notes, the layout and wording should be relatively user-friendly. Even for something as simple as this, there are rules to follow. When demonstrating how a parameter changes over time, place its values in a row and define the time ranges in the column. If you have to show different attributes for competing categories such as genres, put each category on a separate row with an attribute values in the columns. Shouldn't have to put all the data in one table. It could be a better idea to have multiple tables so that each one can reflect an important statistics. Detailing from largest to smallest works wonderfully. Have more detailed tables support your main summary table. Here's an example. First, you have an overview table that covers an entire service. You have more detailed tables for summaries by user, category, city, etc. Keep your team in mind. Try to make your results clear and intuitive for everyone. Okay, so calculate the happiness metric after the experiment has been performed for the entire data set using the instructions from the lesson. Save your results to current happiness variable and print them. Here's you just scroll back to the top and see what they did. Okay. df.sort values by user ID and take the first 1,000, then group by the user ID, and sum. Then find the median, and save it to current happiness. Oop, this is typo. Okay, then print current happiness. Okay, it's 27. Invalid value for variable current happiness. And we don't grab the top 1,000. It says the entire data set, not the first 1,000. That's probably why. Correct. Next. Insert your results into the already established table and calculate the difference between the two values of the happiness metric. Column names, metrics before test, after test, absolute difference. Okay, so we need to do... What do they want us to call the table? So they want us to do exp Oh, I see. They made the table called metrics here. Okay, when you do metrics before test equals 33.154, metrics after test is going to be equal to 36.688. Okay, and the apps metrics absolute difference is going to be equal to 36.688 minus 33.154. Then print metrics. Oops, probably don't need both of these. All right, let's see if that's right. $33.154. Incorrect calculation of the happiness metric before the test. Is instead of like changing it down here, they wanted you to actually input it into this array here. It's literally the same thing. So this obviously has some bugs in it still. But you know, just moving it up there worked. So we'll go next. So we've carried out a lot of work studying the rock and pop genres. Now I'll pull all the data on these genres into a single table. We only need the rock data. So let's get the set of rock songs listened to and save it to the genre rock variable. Then get the maximum minimum listening times and save them to the genre rock max and genre rock min variables respectively. Print them with the following titles. Okay. So we want df dot, let's see, genre rock is going to be equal to df, where df genre name is going to be equal rock. Okay, then we're going to get the minimum maximum. Oop. Genre rock max is going to be equal to genre rock dot max, and genre rock min is going to be equal to genre rock dot min. Print the maximum listening time in the rock genre is colon comma genre rock min. Okay, and then print, we'll just copy paste this because it'll be quicker. The minimum, oh, I have these switched too, by the way. It should be genre rock max, minimum, oh, minimum. The minimum listening time in the rock genre is rock genre min. Okay, so we play. I guess we want at total play seconds. And here we want total play seconds. Hit play. Cool, let's check that. Correct. Next. Compile the results of your investigation in a table called research genres result, which you have to create using the data frame constructor. The data argument is a list of data, and the columns argument is the list of column names. Print the resulting table. Okay, so we have research genres result is going to be equal to pd.dataframe, where data is going to be equal to data and columns is going to be equal to columns. Print research genres result. Okay, let's check it. Awesome. Next. Did you like this course? Sure. What a great intro. Cool. Conclusion, we have found the clear answer to the task at hand. We've laid the groundwork for comprehending pandas, which will be incredibly useful to you in every single stage of data analysis. You're now able to use the methods for removing gaps and duplicates for data pre-processing with confidence, in addition to using grouping and sorting for analysis. Now a word from the man whose task we spent the past 3 chapters solving. Hi, it's the Yandex Music Manager again. It wasn't easy, but you successfully figured out how to work with raw data, and you've also assembled well-arranged statistics. You conquered every challenging stage of analysis, from the initial problem statements to presenting carefully calculated results. Display of your work is ultra user-friendly. You can spot the most significant figures instantly. As we can see, the happiness metric has grown, so integrating radio is a pretty practical idea after all. I have another great idea for you, and I promise that we'll be discussing it soon. Okay, goodbye for now. Thanks, you did it. Next. Okay, so now it's going to walk us through the different professions. So there's 2 practicum professions, analysts and data scientists. It's quite all right if you change direction and switch to another program. The difference is data analysts examine a company's weak points to help find much needed solutions, whereas developers follow their lead. However, when the tried and true algorithms aren't cutting anymore, that's when we need to implement machine learning or mathematical models that formulate predictions based on historical data. This is a data scientist's time to shine because they're familiar with all aspects of data analysis, mathematics, and machine learning. So a sample data analysis project is a retail chain store wants to find potential new areas with the highest concentration of customers and lowest concentration of existing supermarkets. The mobile operator needs to run A/B testing for 2 texts from an ad campaign. The internet store wants to build a dashboard showing conversion rates for various traffic sources. Some things that might require machine learning is a bank needs to automatically predict customers' credit solvency. A search engine needs to identify pictures of adult content so it can expunge them from the search results. And a streaming service is looking to build a recommending system for movies and TV shows and so on. Okay, so the training program for a data analysis tool is data pre-processing, analysis of charts and diagrams, statistical data, collecting and storing data, business indicator analysis, data-informed business decision-making, storytelling and data analysis, automation, projections, and forecasts. Okay, machine learning is introduction to machine learning, supervised learning, machine learning for business, linear algebra, numerical methods, text, time series, and feature engineering, data extraction, computer vision, recommendations, and unsupervised learning. Okay. The ins and outs of the professions. People and machines. Analysts support the decision-making process, meaning they communicate with people more. Data scientists, on the other hand, spend more of their time with machines since their job is to build new mathematical models and programs utilizing AI elements. Mathematics, there's no escaping math when you're working with data. Analysts are all about statistics. It's the primary tool they use to evaluate conclusions to make predictions. Data scientists work with machine learning, therefore they require linear algebra as well as numerical methods. Data analysis, machine learning are powerful tools, although they can be like a locomotive without any cargo when you don't have high quality data. Analysts determine how to collect and store data, and data scientists take over when there are large quantities of data that needs to be processed regularly. As of now, only big league companies deal with quantities such as this. And with that, the series is over. So for the introduction to data scientists, we'll come back when we're actually able to start the. Actually, that was just the introduction of Python in general. So we'll start back whenever this is actually open and we can learn the introduction to data scientists. Okay, thank you guys so much for watching. Sorry this one was a bit long. We just had to finish it up. So I'll talk to you later.